Once we have the distance uh, from each observation to all the others computed, which we have here in d.norm, then we can use those distance values in the H-cluster hierarchical clustering algorithm. So that's the function we're going to use, and let's save the results in HC1. So H-cluster, and the first parameter is the distance object. So the distance object is d.norm, and then we specify the method. Okay, so we've discussed in the chapter discussion the different methods of finding the distance between clusters: okay, single linkage, multiple linkage, and the ward method, and so on. So here are the options we have for method. Okay, so single, complete, average, median, and centroid. Then we have ward.d method. So we'll look at a couple of them. We'll use single and average, but it's just as easy or exactly the same. The only thing that's different is you specify the method right here. And the method, first method we're going to use is single. Right. And then there are other options that we can set, but we're not going to do that. We're going to just use this. Okay, run that, and we have HC1 clusters computed. So you see HC1 is a list object. Okay, so we want to now plot the clusters. So we say plot. If you see HC1 and run, and you get the plot like this. It's kind of doesn't look really nice, does it? So what we need to do is to add a couple of options. So here there is an option called hang, and if you put a minus value, negative value, then all of these row names will be aligned along the zero x-axis, zero y-axis. So you run that, and then you see everything is lined up like that. Okay. Now we can change the labels. Okay, if you say a and n equal to false, all the labels will be taken out. We don't want to do that. A and n false. So what that will do is all the all the labels are gone. Okay, but we don't want that. We want to have some nice labels. So what we're going to do is specify. So we can say main equal to, that's your chart title. So we'll say dendrogram for utilities single linkage. Let's say single linkage. Okay. Now that will put the title up there, and since a and n we have removed a and n equal to false, now we have these titles here for y-axis and x-axis. So the x-axis we can say cluster, and we don't want all these extraneous texts there. So let's say x lab equal to clusters, right? And then y lab, we don't want anything for y lab, so we'll put two quotation marks with nothing in between. So now that is gone. So now we do have clusters, but there is a subtitle there, and to get rid of the subtitle, so we say sub equal to two quotation marks with with nothing in between. So now that's gone. So that looks better. Okay. Now once you have the dendrogram, now we want to then, using the dendrogram, find the clusters. Okay, of course, right at the bottom, each and every utility is a cluster by itself, and as you go up, you have less and less number of clusters. Now, if you want to find the cluster, so we use what is called cut tree HC1, and then you say k equal to, okay, if you want 6 clusters, then we can say k equal to 6, and you click that and you get the cluster. So here each observation, it gives you what cluster it belongs to. So this belongs to cluster 1, cluster 2, cluster 1, cluster 3, and so on. Now that doesn't look really nice. We want to be able to see all the clusters together. So what we will do is we will put this in a data frame and then order it and see which ones form in which fall into which cluster. So first thing we want to do is we want to say member df, right? So the cut tree that we have here down below, you want to put that into a data frame, so we call it data frame. So when you have data frame, you can give a name of a column, so we'll call it cluster, equal to that cluster tree that we generated. Okay, now that's going to convert this information into a data frame. So you run that, then you get memf. So you have the row names maintained here, okay, and then which cluster it belongs to. Now we want to print this by ordered by the clusters, right? So right now, if you do mem.df, so it's going to give you the list as it appears in here, right? In the order in which we had the original data set. Okay, all the clusters are mixed up. We want to order these by cluster, so we can say member f, and then we say order by memf cluster. So now, and we want all the rows to be, so now the rows are ordered by cluster. Now we want all the columns to be printed. So you do that. But then when you do that, then what happens is you just have the clusters ordered. Since there is only one column, it just prints it in a row. That doesn't look really nice. So after the columns, you want to say drop equal to false. Okay, what drops means, okay, by default the row names are not printed. So when you print a data frame, you will find that the row names will be dropped, and you get only the data columns printed. So that's the default. Now if you say drop equal to false, then row names will not be dropped, so row names will be printed. So that way, for each row, you will get the name of the row and which cluster it belongs to. So now you have the row names are printed, and it is ordered by the cluster. So you have all the cluster 1s here, then cluster 2, 3, 4, 5, and 6. Yeah. There is one more function that is useful, that is called rect H cluster. So that uh, draws the dendrogram for us. Okay, HC1. Okay, and then we say k equal to whatever number that you want. Say k equal to 6. Then what this rect H cluster will do is it will put rectangles around the clusters, and we can say what color border you want. So border equal to say red. So now if you run this and you see it prepares the dendrogram and then it puts a border around each cluster. So this is cluster 1 and then 2, 3, 4, 5 and 6. Okay, now let's repeat this. Okay, let's copy paste that and say we want, instead of single, we want average. Okay. So that's the only change we have to make. Okay. And then let's change that to 2 and we'll plot HC2. All right. And then here we will say average linkage. All right. And then in member DF we'll use HC2 with the cut tree. Okay. Now if you run, okay, so that's the cluster based on average linkage, and then the plot. Okay, and set up a memb.df, and then you print. So now you have a different set of clusters, as you can see. And then so here we have the clusters set up